Okay, so the integral of trig functions. So when you integrate sine f of x, f dash x, that will go back to minus cos of f of x plus c. All of these ones I'm doing now, they're all on the formula sheet. The integral of cos, so when you integrate cos, then it's got the f dash x next to it. So cos of f of x times f dash x, that will go back to sine f of x, because if you remember, when you differentiate sine will go to cos and then times the f dash x, so just going backwards. If you integrate sec squared going backwards will give you tan f of x, because the derivative of tan is sec squared, and then you're timesing the f dash x. So basically we're going backwards here. Now for the sine and cos ones, you might notice if you had this sine, cos, minus sine, minus cos, then you go sine, cos. Like if you're going this way, that's differentiation. So sine goes to cos, cos to sine. This is when you differentiate. Minus sine to minus cos to sine, and sine to cos. But if you went backwards, cos integrates to sine to minus cos to minus sine to cos, and cos back up to sine. So I just remember when you differentiate s to c, I think of school, when that's positive, but when you're going backwards, cos will go back to sine. So these integrals are all on your formula sheet. Okay, so looking at this, the integral of sine, so sine will go to, this is another little thing you can do, sc minus s minus c. So when you're integrating, if you're sine will go back to minus cos. So differentiation's that way and integration's going back that way. So sine will go to minus cos 3x, and you've got to put your plus c, that's your constant. Now, the actual rule is the integral of f dash x sine of f of x dx. So the derivative of the 3x is 3, so there's actually a 3 missing, so that means it must have been divided out. That's why you have to put 1/3 out the front. So you can physically put the 3 in and then divide it out, so you can see what's missing, but it's the f dash x that's missing there. The same with here, 4x, really should be a 4 there, but it isn't. So it's going to end up being a quarter, because it would have cancelled the 4 out, and cos will go back to sine x and then plus c. Let's get rid of some of this so I've got a little bit of room there, so plus c. Okay, so we've got sec squared. So sec squared, the integral will be tan, and it will be x on 3 plus c. But if you look at this, this is like 1/3. So the number in front of the x is 1/3. So the derivative of 1/3 x is just 1/3. So technically there should be a 1/3 there. So there must have been a 3 to cancel it out. So it'll be times 3. The integral of sine x, so there should be an f dash x there, which should be a quarter, so it would have been 4 that would have cancelled it out. So it's 4, and sine goes to minus cos x on 4 plus c. To check if any of these are right, all you've got to do is differentiate it. So for example, if you look at the green one, derivative of sine 4x is cos 4x, and then it's times the 4. So it's 1/4 times 4 sine 4x. And see those 4's will cancel out, and you just end up with, so sine will go to cos 4x times the 4, and when you cancel out, you can see you just end up with cos 4x. So cos here will go to sine pi x, and the f dash x there is pi, so technically there should be a pi there, so there would have been a 1 on pi cancelling that out, plus c. The integral of sec squared, so sec squared will be tan, and just going to get myself some room, so it's tan 2x minus pi on 4, and the derivative of the inside of this, derivative of 2x is 2, and pi on 4 just goes to 0. So there really should have been a 2 there, but the 2 had cancelled out, so they must have multiplied by a half, and then we just need to put our plus c. A simple way for simple ones, which isn't on your formula sheet, would be, like if you integrated sine, is just to make it 1 on a cos ax, and it'll be negative, because sine goes to minus cos. Well, sine cos minus sine minus cos. So sine, so when you integrate sine, so it's going that way, it'll go to minus cos. Differentiates that way. The integral of cos ax dx will be 1 on a sine ax plus c, and the integral of sec squared. So the integral of sec squared ax dx, you're just dividing by what's missing, so it's 1 on a tan ax plus c. So you can see the f dash x is what should have been here. Like usually the f dash x is there, which was your a, and that's why we're counteracting that by just dividing by 1 on a. So for an example, if you want to integrate sine 4x dx, so it'd be 1 on a, which is 1 on 4, cos 4x plus c. The integral of sec squared 3x dx, there'd be 1 on 3 tan 3x plus c. I'm just going to do one that possibly is like a little bit harder. 3x on 2, say, dx. Okay, so looking at this, like if you use the 1 on a here, the 1 on a, that would be 1 on a minus cos 3x on 2 dx. And the a is 3 on 2. So 1 on a, we'll just flip it. So it's cos 3x on 2. Because when you divide by the a, so you're dividing by 3 on 2, you end up, that dx shouldn't be there, and that dx shouldn't be there. You end up flipping it, so it's minus 1 times 2 on 3, cos 3x on 2. But what should be there is your plus c, because once I've integrated it is a plus c. So it ends up being 2 on 3. If you look at it just using like what's on the formula sheet, that's f dash x sine f of x dx. So you've got to create the f dash x. So the f dash x is really 3 on 2. But if I multiply by 3 on 2 to counteract that, I times by 2 on 3. So if you're really thinking about this, and that ends up being 2 on 3 times, now sine goes to minus cos 3x on 2 plus c. So it ends up being minus 2 on 3 cos 3x on 2 plus c. And if you wanted to check this, you would have to differentiate it. So minus 3 on 2 times 3 on 2, because that's your f dash x for the cos. Cos will go to minus sine x 3x on 2, and the constant c goes to 0. And see, they cancel and give you 1, and the negatives cancel and give you 1, so you end up with sine 3x on 2, which is what you started with initially, so it does work.